Okay, so we have DD as the series. So let's work on that. DD1. So in this, you're just completing a table. Complete a table. Remember, we're working with absolute value function. So an absolute value function, it just changes everything as a positive. So if you had -2 in the absolute value function, it makes it a 2. And even a +2, it keeps it as a 2. So we are trying to solve tables. So if there were a function fm is equal to m minus 4, and this is where the absolute value of function is. So let's say if there were these values, -10, -5, 0, and 5, right? Now when I put in the value of -10 in here, it becomes a positive, and then I've got to subtract a 4. So this becomes 6, right? Then same over here, I'll get +5 minus 4, which becomes 1. And then I'll get 0 minus 4, which becomes -4. And then the final value is 5 minus 4. The positive values will remain positive. So this is what I get. Now what you could choose to do is go to your calculator and use the y is equal to function, and then go to math. You'll see a button saying math, and then on the top of your screen you'll see ABS, right? Sorry, you'll see NUM before. So there's a number, and then ABS is what you're going to choose. So you go through number and then ABS, okay? And that's how you'll choose the absolute value function option, and then you can just do second table and you'll end up getting these values, and you plug them in, and this IXL will be done that way. Okay, so DD2, here we are graphing the function graph. Alright, so in this again, if you were to take your calculator and go to the y is equal to function, and then click on math, and then you go to number and then abs, this will get you to the absolute value function option, and then you just plug in. Let's say if this is your function, and you'll get the table. Once you get the table, you'll be able to plot the values. So if I were doing this graph, and I put this in and I find the table, let's look at some of the values. So for -3 I get 6, for -2 I get 5, for -1 I get 0, for 0 I get 3, for 1 I get 4, and for 2 I get 5. And I can plot these. So it depends on what the IXL requires. Sometimes it wants you to show multiple points. So let's try plotting it and see what all we can plot on this. So at 1 it's 4, and yeah, it lets you plot 2 points, and you can still get the V-shaped graph. All your graphs will be V-shaped, remember, not a curve. So when I get a curve, that's an x squared graph. When I get a V-shaped graph, it's a absolute value function. Okay, DD3. This is talking about two things: domain, which are all the x values, and the range, which are all the y values. So for example, if a graph is like this, right, and it's passing through the origin. Now what are the x values we can take? The x values are anything on this list, right? So from negative infinity to positive infinity, right? What about the y values? The y values are only above 0. So anything above 0 for y, so that would be a range. For the domain, it can be anything from negative x to y. Think of it this way. Like if I were to talk about your age would only be above 0, right? Can I say negative 3? That's not possible. But what if I were talking about maybe something else, like temperatures? Then can negative 3 be true in that case? So negative 3 is possible, right? So you want to look at it that way, and that's what we are working on in this scalar assignment. And then we have DD5, which is about translations. We've done a few questions with translations. So if you have a standard graph like y is equal to fx, and then if you make this change, let's say if you add something plus a, so what happens is that every y value that you have in fx increases by a. So for example, if you had y is equal to mod x, this is your graph, absolute value of x, right? If this were given to you. And now you modify it to this, y is equal to x plus 3. Now you see some similarities. There's one difference, the plus 3, which is right here, the plus a. So everything on the y-axis will increase by 3. So your graph will actually move 3 units up. So this point goes to 3, right? Same shape, same attributes, but it's moved up. Now similarly, if you were to do y is equal to fx, now that plus can also be minus. So if it were minus, then every y value in y is equal to fx decreases by a. So if we were to draw y is equal to mod x minus 3, I'll put that down here. The graph will be over here. It would move. So we'll take this as a standard graph and reduce everything by 3. So your graph will come down here at negative 3. Now similarly, you can have y is equal to a times fx, right? So like let's say 2 times fx. So multiply every y value by 2. Okay, and you'll get a different graph. Similarly, then you can have graphs like this. Y is equal to fx plus a, right? So when you have a parenthesis with plus a, you do the opposite. Do the opposite. Okay? So this is only applicable to the part when it's in parentheses. When it's out of the parentheses, you do what they're telling you. So here you're doing the opposite. If it's saying plus a, you subtract a from all the x-axis values. Subtract a from all x values. So for example, if we were taking the same thing and drawing this, now this is saying plus 1, so we'll do the opposite. So subtract 1 from all x values. X values. So initially we had this graph, right? Y is equal to mod x. Now when we are drawing x plus 1 in the mod, we'll move everything in the negative direction. So same shape, but it's going to go like this. Okay, so this will be your new graph, and you can use your calculator to your advantage, right? So that guy will help you every time. Similarly, if you have a negative, do the opposite. What does that become? Plus a, right? So if you add a, so if the function were y is equal to x minus 1, and this is only when it's in the parentheses, okay? So minus 1, let's clear it. So what was our initial function? It was like this. Now if I do the opposite, what do I get? This will move in the positive 1 direction, so your new graph will be like this. So it moves by plus 1. This was your standard graph, y is equal to mod x. This is y is equal to x minus 1. Try it. This is a big skill. There are a lot of questions with translations of graphs, so it can be applied to any graphical option that you draw. So try it and see how it works, and do this piecewise. Don't go through this video throughout. Do DD1, just watch that section, then do DD2, watch that section, do the axle, do DD3. Don't rush it. The idea is not rushing. The idea is to understand what is happening. Good luck, and I'll see you on the other side. Take care. Bye.